In November of 2025, a set of freshly processed images landed on Harvard astrophysicist Avi Loeb's desk, taken just weeks after the interstellar object known as 3I Atlas had swung past the sun. Something in those images did not look right. Instead of a normal cometary tail streaming away from the sun the way physics says it should, there was a strange teardrop-shaped glow pointing the wrong way entirely, reaching sunward instead of away from it. Loeb looked at that anomaly and asked a question that sent the entire astronomical community into a fresh wave of debate. What if that glow was not a tail at all, but a cluster of separate objects traveling alongside 3I Atlas, something surrounding humanity's third confirmed visitor from beyond the solar system? This is the story of the object some scientists believe may be surrounding 3I Atlas, why that idea remains genuinely controversial, and what NASA and the broader scientific community actually think is going on. To understand why this question matters, you first need to understand exactly what 3I Atlas is. Discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System Survey in Rio Hurtado, Chile, 3I Atlas immediately stood out because of its trajectory. Unlike the vast majority of comets and asteroids in our solar system, which remain gravitationally bound to the sun in long, looping orbits, 3I Atlas is moving on a hyperbolic path, arriving from interstellar space, swinging once through our solar system and then departing forever, never to return. It is only the third such interstellar visitor ever confirmed, following Oumuamua in 2017 and Borisov in 2019. And it is by far the fastest and largest of the three, traveling at roughly 61 kilometers per second relative to the sun, a velocity so extreme that scientists believe the object may have been drifting through the galaxy for somewhere between 10 and 12 billion years before it ever crossed paths with our solar system at all. That immense age and speed alone would have made 3I Atlas one of the most scientifically valuable objects ever observed, giving astronomers a rare, direct sample of material formed around a star system far older and completely different from our own, a genuinely unprecedented opportunity that partly explains why so many major observatories rushed to study it the moment its trajectory was confirmed. But almost from the moment it was discovered, 3I Atlas began behaving in ways that defied simple explanation. Multiple space telescopes, including Hubble, the James Webb Space Telescope, and NASA's TESS spacecraft, all turned their instruments toward the object as it approached the sun, and the resulting data revealed a series of genuine anomalies that mainstream scientists are still working to fully explain. Its coma, the fuzzy cloud of gas and dust surrounding its icy core, contained an unusually high proportion of carbon dioxide relative to water ice, unlike most comets from our own solar system. X-ray telescopes detected a diffuse glow around its nucleus, making it the first interstellar comet ever observed in X-ray light. And as it passed closest to the sun on October 29, 2025, its brightness increased far faster than standard. Models of cometary behavior predicted, a discrepancy researchers openly admitted they could not fully account for. It was against that backdrop of genuine, unresolved anomalies that Loeb's swarm hypothesis emerged. Reviewing the November images, Loeb noticed that the teardrop-shaped glow surrounding 3I Atlas appeared to point toward the sun rather than away from it, the opposite of what a typical cometary tail should do, since sunlight and solar wind normally push dust and gas backward, away from a comet's sun-facing side. Loeb proposed that this so-called anti-tail might not be a tail made of gas and dust at all, but could instead be explained by a swarm of smaller, solid objects trailing near 3I Atlas. Objects that, because they would not experience the same non-gravitational acceleration from outgassing that a comet nucleus does, could end up appearing to sit in a different position relative to the main body, creating exactly the sunward-pointing glow observed in the images. Before we go any further into exactly how seriously the broader scientific community has taken this idea, if unpacking a genuinely live scientific controversy like this one, rather than settling for a simple answer either way, is the kind of story you enjoy, go ahead and hit like and subscribe right now so you catch the next one. Loeb's reasoning, laid out across several posts on his blog throughout late 2025, walked through the underlying orbital mechanics in real detail, drawing on standard, well-established physics, even as his ultimate interpretation of what that math actually implied about 3I Atlas remained genuinely contested among his peers. Because energy per unit mass remains a conserved quantity along any trajectory shaped purely by the sun's gravity, Loeb argued that if a cluster of smaller objects had originally traveled alongside 3I Atlas at the same velocity and position, differences in how strongly non-gravitational forces from outgassing affected the main comet body versus the surrounding fragments could gradually separate them, with the smaller objects appearing to lag closer to the sun over time. He calculated that Even a relatively small total mass, spread across an enormous number of individual fragments, could produce enough combined surface area to reflect nearly all of the sunlight seen in the observed glow, potentially explaining why the coma appeared so unusually bright relative to typical cometary comas. Loeb was careful to frame this explicitly as a hypothesis rather than a confirmed conclusion, repeatedly asking in his own writing whether the structure represented rocky fragments, icy debris, or something else entirely, rather than asserting a definitive answer either way. That framing matters enormously because it is exactly where mainstream planetary scientists and NASA researchers have pushed back hardest. The dominant, far more widely accepted explanation for 3I Atlas's unusual coma and antitail comes from ordinary, well-understood cometary physics. Comets frequently display multiple jets, narrow streams of gas, and dust erupting from specific active regions on their rotating nucleus, and these jets can create complex asymmetric comas that do not always match the simple, single-tail appearance most people associate with comets. Detailed Hubble observations from January of 2026 actually map this jet structure directly, identifying 3 distinct mini-jets spaced evenly around the nucleus, supplemented by a longer, more prominent jet extending sunward. The same feature Loeb had, identified as a possible antitail. Mainstream researchers studying that same jet geometry have generally concluded that the sunward pointing structure is fully explainable through ordinary sublimation dynamics. Gas and dust erupting from a specific sun-facing active region on a rotating, irregularly shaped nucleus, without requiring any swarm of separate, unexplained objects to account for what the images show. NASA itself has remained firmly aligned with that more conventional explanation throughout the entire controversy, consistently emphasizing peer-reviewed cometary physics over speculative alternatives whenever agency scientists have addressed the question publicly. Agency scientists studying 3I Atlas have consistently described it as a comet, plain and straightforward, pointing to the same fundamental behaviors, sublimating ice, outgassing carbon dioxide, growing brighter, as it approaches the sun that virtually every other comet in recorded history has displayed, even while acknowledging that several of its specific characteristics remain genuinely unusual and worth continued study. Researchers not affiliated with Loeb's specific hypothesis have generally attributed the object's unexpectedly rapid brightening and unusual chemical composition to its extreme age, having formed and drifted through interstellar space for billions of years longer than any comet native to our own solar system, exposed to cosmic radiation and interstellar conditions no solar system comet ever experiences, rather than to anything involving alien technology or an accompanying cluster of mysterious objects. 3I, Atlas's journey through the solar system, also happened to line up with several of NASA and ESA's active planetary missions, giving scientists an unusually rich set of independent vantage points from which to study the object. ESA's Mars Express and ExoMars Trace gas orbiter both observed the comet as it passed within roughly 29 million kilometers of Mars in early October of 2025, while NASA's Lucy mission, en route to study Jupiter's Trojan asteroids, captured its own images of 3I Atlas in September. The European Space Agency's JUICE spacecraft, on its way toward Jupiter's icy moons, added yet another data set from a completely different observing angle, though mission scientists noted that data from those particular observations would not be fully available for analysis until several months later. Having this many independent instruments, positioned at different distances and angles relative to 3I Atlas, gives researchers on both sides of the swarm debate a genuinely valuable set of cross-reference data to work with, since any real physical structures surrounding the object, whether a cluster of fragments or simply an asymmetric jet, should, in principle, appear consistently across observations taken from meaningfully different vantage points. It is also worth being clear about who exactly is proposing the swarm hypothesis, and why his specific track record matters when evaluating how much weight to give the idea. Avi Loeb is a genuinely credentialed astrophysicist, formerly chair of Harvard's astronomy department, but he's also built a public reputation over the past several years, specifically around proposing that unusual interstellar objects might represent alien technology, most notably arguing publicly that Oumuamua, the first interstellar object ever detected back in 2017, could have been an artificial spacecraft rather than a natural object, a position the vast majority of the professional astronomical community rejected at the time and continues to reject today. That history does not automatically make his current swarm hypothesis wrong, since scientific ideas should be evaluated on their own evidence rather than dismissed purely based on who proposed them, but it does explain why mainstream researchers have approached this particular claim with a notably higher degree of skepticism than they might apply to a similarly speculative idea proposed by a researcher without that specific public history of favoring exotic, non-natural explanations. There is also a practical detail worth understanding about why images this far away are so genuinely difficult to interpret with total confidence in the first place. Even at its closest approach to Earth on December 19, 2025, 3I Atlas remained roughly 270 million kilometers away, a distance at which even Hubble's powerful optics can only resolve the object as a small, fuzzy point of light rather than a sharply detailed structure. Distinguishing between a genuine cluster of separate solid objects and a single, irregularly shaped jet of gas and dust, at that kind of distance, pushes right up against the practical limits of what any current telescope can definitively confirm, which is precisely why this specific disagreement has proven so difficult to resolve through imaging alone, and why researchers on both sides have increasingly turned to indirect methods like tracking subtle changes in brightness and position over time in an attempt to settle the question, is that it is, at its core, a genuinely unresolved, ongoing debate rather than a settled question in either direction. Loeb's specific mathematical reasoning about orbital energy conservation and differential acceleration is not fringe physics. It is grounded in real, standard orbital mechanics, even if his interpretation of what that math implies about 3I Atlas specifically remains disputed. At the same time, the conventional jet-based explanation embraced by NASA and most mainstream researchers is also grounded in decades of established cometary science, directly supported by the specific jet geometry Hubble's more detailed January 2026 observations actually mapped out. Resolving the disagreement definitively will likely require exactly the kind of continued careful observation astronomers are currently racing to complete, since 3I Atlas is now moving rapidly back out of the solar system, already more than 1 billion kilometers from Earth as of mid-2026 and growing fainter with every passing month, leaving researchers on both sides of this debate a narrowing, genuinely finite window to gather the additional data that might finally settle which explanation actually fits the evidence best. Whatever the ultimate answer turns out to be, 3I Atlas has already secured its place as one of the most intensively studied interstellar visitors in the short history of this entire field of astronomy, observed by an unprecedented combination of ground-based telescopes, orbiting space observatories, and even spacecraft stationed near Mars and Jupiter that happened to be in position to catch a glimpse as the object passed through. That level of scrutiny is precisely why disagreements like the one between Loeb's swarm hypothesis and NASA's more conventional cometary explanation matter so much to the broader public understanding of how science actually works, offering a rare, transparent window into exactly how competing interpretations get weighed, tested, and eventually settled within the scientific community. Genuine scientific uncertainty is not a flaw in the process. It is the process, playing out here in real time, with credentialed researchers examining the exact same images and data and arriving at meaningfully different conclusions about what they show. A disagreement that will most likely only be resolved through further peer review, additional data analysis, and time, rather than through any single dramatic announcement. If watching a real, unresolved scientific mystery unfold, with credentialed experts genuinely disagreeing about what the data actually means, is the kind of story that keeps you coming back, make sure you are subscribed and have hit like on this video, because there are plenty more stories like this one still developing right now. For now, 3I Atlas continues its long journey back out into interstellar space, carrying with it whatever secret actually explains that strange sunward-pointing glow, a swarm of small fragments as Loeb proposes, an ordinary jet of sublimating gas as NASA and most mainstream researchers maintain, or possibly some combination of dynamics scientists have not yet fully considered. Either way, the object is departing faster than most telescopes on Earth can keep pace with, meaning whatever final answer the scientific community eventually settles on will likely be built entirely from the data already collected during this narrow, rapidly closing window when 3I Atlas was close enough and bright enough for humanity to actually get a good, careful look at it, a window that, by every measure available right now, is already closing for good.